Question 49, Instrumentation Engineering Gate 2022. The matrix A is given to us. It has eigenvalues of -5 and 7. The eigenvectors are dash. 4 options are given to us. This is a multi-select question. Reference to the NPTEL course would be to refer Module 7, Lecture 26, Eigenvalues and Eigenvectors of Linear Operators in the course of Linear Algebra by Dr. K. C. Shivakumar, Department of Mathematics, IIT Madras. Let's first understand how to find out the eigenvectors of a matrix so that we can just decode the question to find out the eigenvectors. Before all this, we will first know what an eigenvalue is. Eigenvalues are the solutions to the characteristic equation. If a matrix is 3 cross 3, this will have 3 eigenvalues. Similarly, if a matrix is n cross n, it will have n eigenvalues, and each of that eigenvalue will have an eigenvector corresponding to it, which will satisfy the equation a minus lambda I into x is 0. So, to find out the eigenvectors of a matrix, let us follow the procedure. First, we have to find out the eigenvalues by solving the characteristic equation, and then substitute each of the eigenvalues in the equation Ax is equal to lambda 1. Let us say we have a 2 cross 2 matrix A, B, C and D, and the eigenvalues are lambda 1. So, A minus lambda 1, B, C, D minus lambda 1 would be A minus lambda 1 times I. This into x1 comma y1, let us say this is the first eigenvalue, this is 0 comma 0. Upon solving this equation, we will be getting the values of the eigenvectors x1 comma y1. Similarly, for the other two values, let us just decode the given information, which says that this matrix has two eigenvalues 5 and 7, and then we can find out the eigenvectors. The matrix A is equal to 4, 3, 9, minus 2, and the eigenvalues lambda 1 is equal to minus 5 and lambda 2 is equal to 5. So, the value of A minus lambda I times x is equal to 0. Let us do this for the first eigenvalue minus 5. If we do this, we will be getting 4 plus 5, 9, 3, 9, minus 2 plus 5 will be 3 again. So, 9, 3, 9, 3 times x1 comma y1 is equal to 0 comma 0. So, this is a linearly dependent equation. So, the equation is 9x1 plus 3y1 is equal to 0. If we reduce it, we will be getting 3x1 plus y1 is equal to 0. Let us say x1 is k. And what would be the value of y1? y1 would be minus 3k. So, the first eigenvector corresponding to the value lambda is equal to minus 5 will be k and minus 3k. Let's do the same for the other eigenvalue, which is 7. I am sorry, lambda 2 is not 5, it is 7. Lambda 2 is equal to 7. If lambda 2 is equal to 7, we will be getting the values 4 minus 7 is minus 3, this is plus 3, 9, 2 minus 7 will be minus 9. This into x2 comma y2, this is equal to 0 comma 0. So, this is also a linearly dependent equation, which is minus 3x2 plus 3y2 is equal to 0. If we further reduce, we will be getting minus x2 plus y2 is equal to 0. So, this in other words means x2 is same as y2. Let's say x2 is equal to m, then this implies that y2 is also m. So, lambda 2 is equal to 7 implies that the eigenvectors will be m and m. Let us first see the options, because this is a multi-select question. Option 1 is 1 comma 1. This corresponds to lambda 2. Option 2 is not really, option 2 doesn't correspond to any of these eigenvalues. Option C is 2 and minus 6, which corresponds to lambda comma 1. Option D is 2 and 8. It doesn't depend on any of these eigenvalues. So the correct answer is option A as well as option C. This is a multi-select question. The correct answer is option A and option C.